Welcome to Class 8 Mathematics Chapter Power Play. Today we tackle a mind-blowing question about digital locker passcodes. Imagine a locker with 5 slots, each can hold a digit or a letter. Codes like G89P0, 38098, BRJKW, or 003AZ are all valid. How many such codes are possible? The answer will amaze you. We break down questions step by step to help you understand better. Hit like and subscribe to support the channel. Before we tackle the full locker, let us think simpler. A 2-digit lock. Each slot has 10 choices, 0 through 9. The digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 10 options. For the first slot, 10 options. For each of those, the second slot also has 10 options. So 10 times 10 equals 100 possible codes. Now extend this to 5 digits, 10 to the power 5 equals 1 lakh combinations. But our locker is not just digits, it is alphanumeric. Let us count those characters. Alphanumeric means digits and letters. The digits 0 through 9 give us 10 characters. The uppercase letters A through Z give us 26 more. But here is the key insight. In a digital locker, uppercase G and lowercase g are different characters. So lowercase a through z adds another 26. That is 10 plus 26 plus 26 equals 62 possible characters for each slot. See, G89P0 and G89P0 are different codes in a digital system. That is why we count both uppercase and lowercase, giving us 62 characters per slot. Now here is where the magic happens. Remember our warm-up? Each slot had 10 choices, so we multiplied. Same idea here. Each of the 5 slots has 62 choices and they are all independent. Slot 1 62 options. Slot 2 62 options. Slot 3 62. Similarly slot 4 62. Slot 5 62. Slot 5 62. So we multiply 62 times 62 times 62 5 times. That is 62 to the power 5. Same pattern as 10 to the 5 for digits only, just with 62 instead of 10. Now let us compute this monster number. Let us compute step by step. 62 squared equals 3844. Multiply by 62 again and we get 2,38,328. Again, 1,47,76,336. And one more time, we need to multiply this by 62. Let us break it down. We can break 62 into 60 plus 2. 14,776,336 times 60 equals 886,580,160. And times 2 gives us 29,552,672. Add them together and we get 916,132,832. 916,132,832. Over 91 crore possible passcodes. That is why digital lockers are so hard to crack. Here's the method you can reuse for any counting problem like this. Step 1. Count how many choices each position has. Here, 10 digits plus 26 uppercase plus 26 lowercase equals 62. Step 2. Count how many positions there are. Here, 5. Step 3. Raise the first number to the power of the second. 60 to the power 5. The big idea? When each choice is independent, multiply. Every time you create a password, you are using the multiplication principle, and now you know exactly why longer passwords with more character types are exponentially harder to crack. Keep learning and keep growing. See you in the next question.